These notes are on combined gas laws. So the combined gas law has pressure, volume, and temperature. So these are the same formulas we've been using to get before, except for they're all together combined. So here's pressure and volume that we used the first day. Here's volume and temperature that we used the second day. And here's pressure and temperature that we used the third day. So we can put them all together into this new formula we call the combined gas law. Now the important thing to remember is, like all of the other ones that have temperature, your temperature must be in Kelvin. And secondly, pressure units have to match. So if you have ATM here, you have to have ATM on the other side. And your units for volume have to match. So if you have liters over here, you have to have liters over here so that they will cancel. So let's go ahead and do our first example. So go ahead and copy this down. This says we have a sample of methane gas, and it has a volume of 2 liters at 4 ATM and negative 173 degrees Celsius. So those are our initial values. We want to find out what is the Kelvin temperature when the pressure is 1520 torr when the volume is 2 liters. So we need to write down all of our variables. So we have P1, V1, T1. Remember, these have to all go together. So in the first sentence, it's telling you that this gas has a volume of 2 liters. So that is our first volume. It has a pressure of 4 ATM. So that is our pressure. And then we have a temperature of negative 173 Celsius. So that is our temperature. So our pressure is 4 ATM. Our volume is 2 liters. And our temperature is negative 173 degrees Celsius. So since we know we have to change temperature to Kelvin, let's go ahead and change it right now. So we have to add 273. So that means our temperature is going to be 100 degrees Kelvin. All right, let's look at our second conditions. This says that our pressure is 1520 torr. So P2 is 1520 torr. Our volume is 2 liters. So V2 is 2 liters. And we're trying to find the temperature. So that means our second temperature is our unknown. That's our question mark. We don't know what that is. So we don't have to change that to Kelvin, obviously, because that is what we're looking for. Let's look at our other units. So our first volume is in liters. Our second volume is in liters, so that is good. Our first pressure is in 4 ATM, or I should say ATM. Our second pressure is 1520 torr, so they do not match. So switch 1520 torr into ATM. So remember, when you do that, you have to divide by 760. So there are 760 torr in 1 ATM. So this is a memorized one. You should by now know what 1520 torr is. So that is 2 ATM. All right, so now we are ready to plug it all in to our formula. So let's get a new board. Okay, so our formula is P1 V1 over T1 equals P2 V2 over T2. So we plug everybody in. So we have 4 ATM times 2 liters divided by 100 Kelvin equals 2 ATM times 2 liters divided by our temperature. All right, so now let's go ahead and cross multiply. So when we cross multiply, we are going to have 4 ATM times 2 liters times the temperature. And then this is going to go up here, so we're going to have 2 ATM times 2 liters times 100 Kelvin. Okay, so this is the way you do all of your problems, just like we have been doing. You substitute, you cross multiply, now we have to isolate our variable. We have to get T2 all by itself. We need to get these other numbers over to the other side, so then we can simplify. Do not start doing your math until all the numbers are on one side. So that means we're going to have to divide both sides by 4 ATM and 2 liters. So we'll divide this side by 4 ATM and 2 liters. So let's notice that these are canceling, so they're totally gone. Let's simplify our units over here. So we have ATMs canceling with the ATMs. We have liters canceling with the liters, so we're left with Kelvin, which is a good thing because that is what we're looking for, temperature. So T2 equals 2 times 2 times 100 Kelvin divided by 4 times 2. Well, there's a number of ways you could do the math here. Basically, this is 4, right, which will cancel with that 4. So we have 100 divided by 2. So our temperature is going to be 50 Kelvin.